So let's move on to the next question, guys. In this question, we are given that there is a square which is inscribed in a circle, right? Which is again inscribed in a larger square. So we have to tell the ratio of the perimeter of the larger square to the perimeter of the smaller square, right? So let's draw the figure for this. So we know there is a square which is inscribed in a circle, right? So let's suppose this is a circle. So this is a circle, right? And we have to inscribe a square inside this circle. So let's say this is the square. I hope this makes sense, right? Which is inscribed in a larger square. That means this circle is inscribed in a larger square. That means what is the figure? The figure becomes this, right? I hope this makes sense, right? So there is a square which is inscribed in a circle, which is inscribed in a larger square, right? So now we have to tell the ratio of the perimeter of the larger square to the perimeter of the smaller square, right? Okay. So let's suppose that this is the center of the circle, right? And the center of the squares. And let's say this is the radius r, right? In this circle, this is the radius r. And if you join this will also be r, right? This is the radius, this whole thing is the diameter. This is the center C, right? So this is r, and this is also the diagonal of the square, right? Okay, perfect. Now tell me one thing. If this is the entire diagonal, so for the smaller square, right? What is the diagonal? The diagonal is 2r, right? So for the smaller square, if you see, the diagonal becomes 2r, right? If we suppose this side is x, this side is x, right? Let's assume this. So x square plus x square is equals to 2r square, right? So 2x square is equals to 4r square, x square is equals to 2r square, x is equals to r root 2, right? That means the side of the smaller square comes out to be r root 2. I hope this makes sense, right? So this side, the side of the smaller square comes out to be r root 2, right? If the side is r root 2, how much will the perimeter be? In that case, the perimeter of the smaller square, the perimeter becomes 4 times side, which is 4r root 2. So this becomes the perimeter of the smaller square. I hope this makes complete sense. It's pretty simple, right? Okay. Now tell me one thing. What is the side of the larger square, right? If you talk about the larger square, which is this, right? So what will be the side of this larger square? Tell me one thing. If this is a circle, right? So obviously this will be the radius starting from here till here, which is passing through the center. This will be the diameter, not the radius, sorry, the diameter. So this will be the diameter, right? For this circle, if we take a line passing through the center from this end to this end, this will be the diameter, right? And we can see this part is equals to this part, basically, right? So what is the diameter? The diameter is r plus r, which is 2r. So this is also 2r, so this is also 2r. So this becomes 2r. I hope this makes sense, right? So what we initially did was that firstly we assumed the radius r. So for the smaller square, this diameter becomes the diagonal, right? But for the larger square, the diameter is equal to the side of the square, right? So for the larger square, right, what is the side? For the larger square, the side becomes how much? 2r, right? So what will be the perimeter be? The perimeter becomes 8r, right? 4 into 2r, which is 8r. I hope this makes complete sense. So we have found the perimeter of the smaller square, which is 4r root 2, the perimeter of the larger square, which is 8r. Now we have to find the ratio of the perimeter of the larger to the smaller. So what is larger? 8r upon what is the smaller one? 4r root 2. So r gets cancelled, 4 to the 8. You can write 2 as root 2 into root 2 upon root 2. So this gets cancelled, so your final answer becomes root 2. So the ratio of the perimeter of the larger square to the perimeter of the smaller square becomes root 2. I hope this should be clear.